Alright, welcome back to Scholar Strive, doing some Algebra 2. Today we'll be looking at properties of logarithms. This is going to be one of those sections where you just need to practice, and you'll start remembering all the different types of rules as we go over them. So the identity properties. So right here, remember that a to the 0 is 1, and a to the first is a. So log base a of 1 is the same thing as a to the 0. Anything to the 0th power is 1. And then when you have log base a of a, you'll get a. Because this is the same thing as a to the first power. And then let's look at the inverse properties. So if we take the log base a of a, those cancel, and you're left with x. And same thing if we're taking a to the log base of a, those cancel and you're left with x. So let's do a little bit of examples. So for example, for the identity, log base 5 of 1 is 0. Or log base 5 of 5 equals 1. This one, if we take the log of 5, log base 5 of 5 to the 7th, those cancel, and I'm left with 7. And same thing, 7 to the log base 7 of 5, because those are the same base, those go away, and you're just left with 5. Product rule. Log a of mn equals, okay. So basically, if you have two numbers being multiplied together, you can split them into two logs. And reuse the addition sign. So for example, if I have log base 2 of 4 times 3, that is equal to the log base 2 of 4 plus the log base 2 of 3. Okay? So when we have two numbers that being multiplied, we can split it into two logs being added together. Or vice versa, if we have two logs of the same base being added together, we can combine their two values by multiplying them together. So if we had log base 2 of 4 plus log base 2 of 3, that would equal log base 2 of 4 times 3, which would be 12. Okay, quotient rule. If we have a number divided by a number, we can split it up into two logs that are being subtracted from one another. So if we have log base log base 3 of 7 over 5, that would be equal to log base 3 of 7 minus log base 3 of 5. And vice versa, you can combine them. So if we had log base 3 of 7 minus log base 3 of 5, that becomes log base 3 of 7 over 5. Alright. So if we're taking the log that has an exponent that's not equal to the base, or if we're taking a log of something, the log base b of not the same base to a different exponent, we can change it. So this would be, for example, log base 2 of, let's say, 5 to the third. We can call this the same thing as 3 times log base 2 to the fifth of 5. And vice versa. If we have 3 log base 2 of 5, that is the same thing as log base 2 of 5 cubed. Change your base. Okay. So sometimes we want to work with easier bases, usually log base 10, because log base 10 is in our calculator, and we can use it. So if we want to change our base, so log base 7 of 5, that would be the same thing in putting our calculator, log base 10 of 5 over log base 10 of 7. Okay. And we can also do this, we can also change it to a natural log of A over a natural log of C if we wanted to use it. Either way it works. So we can use log or natural log. Alright, let's do some example problems. So use the fact that log base 4 of 3 is 0.792 and log base 4 of 7 to 1.404 to evaluate the following 4 logs. So basically they don't want us to use our calculator. So we're going to use our quotient rule for this one. This is equal to the log base 4 of 3 minus the log base 4 of 7. Okay? So that would be 0.792 minus 1.404, which would be we would put in a calculator. But we're just using these facts to practice our quotient rules, or just our product rules and all our different properties. So log base 4 of 49, we would set that equal to the log base 4 of 7 plus the log base 4 of 7. Because 7 times 7 is 49. This one is the log base 4 of 7 plus the log base 4 of 3. Okay. So once again, this would be 1.404 plus 1.404. This would be 1.404 plus 0.792. Log base 4 of 12. Would be log base 4 of 4 plus log base 4 of 3. Now remember, log base 4 of 4 is just 1. And log base 4 of 3 is given 0.792. Alright, expand log base 6 5x cubed y. So they want to expand it. So we're going to have lots of logs. So we know things being multiplied get added. So log base 6 of 5 plus log base 6 of x cubed minus log base 6 of y. It's a minus sign because it's being divided. And then there's one last step. I'm going to change the middle one. If we have an exponent, we can move it to the front. So 3 log base 6 of x. Okay. Now we want to condense this, make it all one natural log. So this is the natural log of 4 times 3. Oh, wait. This would be the natural log of 4 plus, or times, sorry. So I'm just going to, yeah. So this middle number is what's messing me up. This is the ln of 3 to the third, which is 27. So this would be the natural log of 4 times 27 over 12. So this would give me the natural log of 108 over 12, which is the natural log of 9. Evaluate using the base change. So this would be log of 3 over the log of 8. Punch that into your calculator, and you should get something. You can also use the natural log of 3 over the natural log of 8. And then we got a physics problem where it's useful. The intensity formula. Loudness equals decibels. So this is loudness equals decibels. This is where the formula comes from. IO is that. So you figure out your, whatever your intensity is, and then you do 10 times log of, sorry. So you would do your intensity over your I sub O, and then you would take the log of it, and you multiply it by 10 to get you to see how loud it is. Well, hopefully you practice more of these. Hopefully this helps you out. I'll see you later.